Lesson 28, part 2 is about prisms. And we're going to start this lesson by just looking at actually one of my web pages. This is a trip I did down near the Castle Mountain Ski Resort down in southern Alberta. And as you can see, it's called Paradise Lake and Hague Ridge. And you may notice the unusual color combination of the title here. I'm sure you recognize that as Roy G. Biv. And what's in the middle here? A couple of rainbows. Big rainbow there, big rainbow. Anyway, this is a very cool trip because of the unusual weather phenomena. And I saw tons of rainbows on that trip. There's another one. And there was some really bright ones. This was on the drive there. And then this one, which you've seen already. And blah, 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 blah. This is just part of the trip. And then on the way down, oh, come on. Oh, there we go. There's another rainbow here. And I think there's some more. There's one more. One more. One really bright one there, or close up of a bright one. And that's it, I think. Oh, there's one more. So anyway, oh, more there. Tons of rainbow and lots of fall colors. So I saw lots of rainbows on this trip, which is all explained by dispersion, prisms dispersion, and which is obviously a form of refraction. And it said that all explains rainbows. Prisms. What is a prism? A prism is basically just a piece of glass that is going, the light is going to go into the glass, as you can see in this diagram, and when it gets in the glass, it's going to refract. Now, what's special about these prisms is that when it refracts into the rainbow of colors. Why does that happen? Why does it happen? Well, it happens because of dispersion, and it happens because of Snell's law. This is part of Snell's law. And you can see that wavelength is in this formula. And each color has a different wavelength. The wavelength of red is 700 nanometers. Blue, 400 nanometers. So as stated in this formula, the different wavelengths of light will reflect at different angles. Sorry, refract, I should have said. They will refract at different angles, and that's why when the white light, and white light is composed of all the colors of light, when the light goes into a prism, the different colors reflect at different angles, and that's why it breaks out into Roy G. Biv, the colors of the rainbow. And in your diagram, as you can see, it happens once when it goes into the prism, and then it happens again. And if you were writing your diploma, or if you are writing a diploma, because maybe I'll use this video for future classes, this is really important. Very important. The shorter wavelengths, like violets, refract the most, and the longer wavelengths, like red, refract the least. As you can see in this diagram right here, red is refracting the least, violet is refracting quite a bit. Okay, so once you got that, then you should really go, there's a really good video here, go to YouTube and Google this, refraction of light experiment, dispersion of light through a prism. This is a really good video that explains things quite well. Okay, and you can also look through your notes. Your notes go to explain why rainbows are formed, why they formed, because water, why do you see rainbows when it rains? Because the light refracts and reflects through droplets of rain, forming the colors of the rainbow. And this is why you can never get to the end of a rainbow, because it depends on the angle in which you're looking at it. And as soon as you start traveling towards what you visualize as being the end of the rainbow, the angle has changed to the point where the refraction doesn't occur from your angle, which is why you should never try to find the pot of gold at the end of the rainbow, because you will never get there. Sad. And that is it. That's prisms. Farewell.